Okay, so the second page is just a bunch of practice, so you may want to do this part before you watch the videos. But you can just take this first example, rewrite it, times the quantity times itself, and FOIL everything out. And you end up with 4x to the fourth plus 2x squared y cubed plus 2x squared y cubed plus y to the sixth. And combining your like terms, you get 4x to the fourth plus 4x squared y cubed plus y to the sixth. As straightforward as that. This next one is kind of an interesting example, just looking at two numbers that we could rewrite as a difference of squares. So if we realize that the number 40 plus 1 is 49, and the number 40 plus 1 is 41, and the number 40 minus 1 is 39, that becomes a difference of squares. And using the property, you just know you multiply the first term and the last term because the middle terms will cancel out. And so that's just an easy way to look at something that you might need to multiply if you can rewrite an actual number as a difference of squares. So there's two different examples down here for you to try. Again, this first one is a difference of squares, so I know that the middle term will cancel out, and I just need to worry about the first term and the last term. And so we get 9x to the fourth minus 25y to the sixth. And if you ever get confused about what your exponent should be, just remember you add exponents when multiplying. And this last one is just a sum of squares, and you can rewrite that if you would like, or this is just kind of a silly one. I'm not even going to worry about it, but it's just saying you would write this out as this. And then you could use the formula to multiply everything together. But I'm not too worried about this, so we can continue on. In the next page, factoring and simplifying expressions, this again is just using those four formulas on the first page to factor. All right, so recognizing that this is a difference of squares and knowing I can just square root the first term and I get 3m squared, and square root the second term and I get 5n cubed, and then rewrite the same thing with a plus sign. And that should do it. So that is your final answer, 3m squared plus 5n cubed and 3m squared plus 5n cubed. So you have a minus and a plus. This is a difference of cubes. And just remembering your sign, cube root the first number, cube root the second number, which happens to be 6, square the first number, plus sign, multiply them together, plus sign, square the second number. Okay, final answer. Again, if we wanted to use the sum of cubes here, we could. It just turns out quite interestingly, you take the cube root of the first number and the cube root of the second number, square the first number, minus sign, multiply them together, plus sign, square the second number. And then you can just simplify this. This is 16. This whole thing is 91. Multiply them together and you get 1,456. So just another way to do that formula. And finishing up the you-dos, we will do that on the next slide. So take a break and check that out.